In this video, we continue our discussion of summary queries. We're in the same slideshow as the previous video. You should be logged into SSMS using the grocery store credentials, which are published on Blackboard and will not be repeated here for security reasons. Our first query is the natural language question: what customer or loyalty number has had the most transactions? At the bottom of the slide, I listed a set of steps you might follow to solve this query. We have to join two tables together to relate customers and transactions. We know that because we've already studied our grocery store database in previous videos and assignments. Next, we group that result set by customer. Then we summarize each group by counting the number of rows in that group. Then we sort in descending order by the count of the transactions. This should actually be transactions. And then we take the top one, which would be the customer or the loyalty number that had the most transactions. In SSMS, I have roughed out the pattern or the template for creating a query like this. And remember, this is a little confusing because these things don't really read from top to bottom, and when you build them, you may not build them from top to bottom. But if you think about the keywords that have to be provided: select, from, inner join, on, where, group by, having, and order by, those have to be in a certain order. Now, we're not going to use all of these in this first query, but we will eventually use them, so it's nice to see them all written out. Step one, join customers and transactions. We need to know how customers relate to transactions. In the transaction table is a loyalty ID. One loyalty ID represents one customer. We see that it is an integer, so it could be a foreign key. We look at the loyalty table, and as we expect, since the table is called loyalty, it has a surrogate key, which is also the primary key, called loyalty ID. And we realize then that based on our naming convention, we can relate these two tables. The primary key is in the loyalty table, the foreign key is in the transaction table, and it is a one-to-many relationship. One loyalty ID, one customer will have zero-to-many transactions in the transaction table. Just like in the real world, a customer may visit a store or any store in the chain many times. One-to-many relationship. One customer, many transactions. Let's build our join. We will skip the select because we're not there yet in our recipe, but we can build the join. Select, from T loyalty, and we'll call that L. Inner join T transaction, and we'll call that T on. And we just looked at the common field. The related field between the two tables is loyalty ID. T dot loyalty ID equals L dot loyalty ID. Is there a where clause? There does not appear to be a where clause in this. We are not filtering any particular rows in each group. We can delete that, or we can comment that out because we don't think we need it at this point. Is there a group by? Yes, there is. We want all this information to be summarized by customer. Well, we can group on any key value. We can group on loyalty ID, we can group on loyalty number because they're both keys. Loyalty ID is a surrogate key. Loyalty number is a natural key. Let's group by loyalty number. That would be the number that you're given when you shop at those stores so they can track you. Is there a halving clause? Do we need to filter out some of the groups for any reason? There does not appear to be a halving clause. We want all the groups. We can comment that out if we like. And we want the top one, but the top one of what? Well, it appears that we want the count of transactions per group. And then I can order by whatever I've got in my select clause. So I'm going to put two things that I want in my query results set. I want the number of transactions in each group, which is going to give me this. And I want the loyalty number from each group, which is the loyalty number field. The order by should be the count, because I want to take that number with the highest count, sort by count of transactions, so order by, and that's going to be that field. Descending order, because I want the highest value. And at any point where I think I have a properly built SQL statement, I can execute it. Let's try it now and see what we get. And we don't appear to be logged in. Excuse me just a moment. I got knocked off the network for some reason, but now I'm back. I can run this query. There's my results. I have the total number of transactions per customer, per loyalty number. And I see that one particular loyalty number has 10,000 transactions, and then 3 more have relatively small numbers of transactions. So these numbers don't mean a lot in the real world. We wouldn't expect one customer to have 10,000 transactions and only 3 other customers to have purchased anything at all. But it works for us. We don't consider this to be real world data at this time. And that would be the solution for this, except in step 5, you'll notice we only want the customer with the most transactions. Therefore, I can go top 1, and that gives me the total transactions and the loyalty number for the customer with the most transactions. And that is a reasonable solution for this question. If we were to specifically be very picky about this question, we would see that it's just asking for the customer or the loyalty number, but it's a pretty safe bet that whoever wants to know the answer to this would also want to know how many transactions there were. If you gave me this as a solution, I would be more than happy with it, even though the question in specific is only asking for the customer. But I'm perfectly okay with those 2 columns of information as a solution for this query. On the next slide, just tweak it a little bit. What are the top 10 customers with the most transactions? Pretty simple. All we need to do is select the top 10. We still have a descending sort by total transactions. And I highlighted something, forgive me, I tried to execute what was highlighted, which makes no sense. Execute. There's the 4 that we saw before. There aren't 10, there are only 4. because only 4 people have shopped in our stores at this point. So we don't get 10, but we also don't get an error, which is nice. Even though we asked for 10, there are only 4. We get those 4. If someone comes in tomorrow and buys something, there would be 5. And if we ran this query again, we would get a different result. That was pretty simple. On the next slide, we will build on what we've already done. What customer has had the most returns? Rather than total transactions, what customer has come back in the store the most times to return something? If you look at these steps, you notice they are very similar to what we've already done, except we added a filter. In step 2, we only want returns as the transaction type rather than all types of transactions that we had in the previous query. How do we do that? Well, in the transaction table, there is a transaction type, and you can see it's a foreign key. Okay? And since it's a foreign key, we know that it relates to another table, and by our naming convention, the table that it relates to is going to be transaction type. Let's look at transaction type, what's in there. There is a refund transaction type. Being a little bit imaginative, is a return transaction the same as a refund transaction? It sounds like they're the same. The customer brought something back and got a refund for it. I would say yes. And if you're not sure, I encourage you to ask someone who has knowledge of the semantics of the database. If you're not sure if a refund and a return are the same thing, if you're not clear on what refund means, what return means, in this particular situation, you post a question on the discussion board and I will answer it. In the real world, you find someone with domain knowledge, you find someone who knows what these words mean, and they will help you. Don't struggle with the semantics. Don't stress out over what the fields are, what the words mean. Ask someone. The worst thing you could do is spend a day or even a week trying to figure out exactly what these words mean when there is someone who can help you immediately. We need to add this filter to what we've already done to get very close to what we need to answer this question. Going back to what we did earlier, we can edit the where clause. And add transaction type ID equal to, uncomment that. This gives us the count of transactions by loyalty number only if the transaction type is 2. We want to know how many transactions type 2 did each loyalty number execute. How many times did each customer bring something back to the store? And we can see that there are only 2. 2 customers each brought 1 transaction back to the store. That transaction could have been 10 items or 1 item, but we're just concerned now about trips back to the store to return something. And there's our solution. All we added then was a where clause. The query that we'd already written was applicable to what we wanted to do as long as we were willing to filter the transaction type. Since we just did a where clause, let's talk about where and having and how they work. On slide 24, brief summary of having and where. Where is applied before the group by. Having is applied after the group by. We can filter the records that go into each group in the where clause. We can filter the groups that are created with the having clause. Both of them are filters. One is applied before the grouping and one is applied after the grouping. And if you look back at the SSMS query window again, you can see that they're separate, and you can have one, you can have order by if you aggregate or not, but you must have aggregation to use the having clause. What's our next question? What total stores in Ohio have more than $1,000 in total sales, and list those stores in descending order by total product sales? If we were very strict, we would just list the total sales, which would produce a column of numbers without a lot of meaning. So it would probably be more friendly to grab the stores and list the store names or store numbers along with the total sales, so that we have some more useful information in the results of this query. Our strategy will be filter the stores using a where clause. That's before the group by. And then after the group by, filter the aggregated results with the having clause, and that is going to limit us to stores that have at least $1,001 in total sales, more than $1,000. We'll be using a where clause and a having clause. Let's start a new query. We can say use grocery store. We probably don't have to at this point because we've kind of defaulted to the grocery store, but it can't hurt. It's not part of the query specifically, but it is part of the way that we get SSMS to do what we want it to do. And let's create our clauses. Select from inner join on, and what were the other clauses that we used? You can always look back here. Where, group by, having, and order by. After I built this little template, I usually start with the from to create a broad result set that I can then group and filter and sort as necessary, but I can't do anything without that result set. What result set do I need? Well, I need stores because it wants to know stores in Ohio, and I need total sales because it wants me to limit those to greater than $1,000. Somehow I need to connect stores and total sales. I have to play detective again, and I have to figure out where the stores are, what table, and where the total sales are, and then I have to relate those two together. If you don't know how, you need to investigate the structure of the tables, read the documentation, ask for help, and then once you understand that, you'll be able to do it down the road when it becomes necessary. I will tell you that the store table, which hopefully you've already realized based on our previous work, has the store information in it. But if I look at the transaction detail, there is a total price. And we will use total price as the value to answer the question total sales. We will assume total price and total sales are the same. I'm telling you just to use that assumption. That works fine for us at this point. Again, if you're not sure, post a question in the discussion board and it will be answered. But the problem is there is no store ID, foreign key, in the transaction detail table. How do I get from transaction detail back to store? That's the issue. Well, let's cheat a little bit and I'll tell you that the transaction table has a store in it. And the transaction detail has a transaction foreign key in it. I need to join 3 tables to get stores and total prices in my results set. Let's start by joining store with T transaction. Give that an alias T. And I want to join on store ID S dot store ID equals T dot store ID. And then let's do another inner join. Take that result set and join that on transaction detail. I call that TD. It's a nice alias. Inner join transaction detail on. And what are my common fields? I have a common field between the transaction table and the transaction detail table. TD dot transaction detail equals T dot transaction detail. There's my results set. Does it work? Well, at this point we really can't tell because we haven't built enough SQL to be syntactically correct. We could, if we're not sure if our join is correct, we could put something in here, S dot store, and then we could comment out everything else just to see if this works. Okay, that did not work. It says invalid column name transaction detail in 2 separate lines. Well, actually in one line, line 8. So I assume that's line 8. And I did a typographical error there. It should say transaction detail ID, transaction detail ID. You can see how doing a little bit of debugging or intermediate testing can save you a lot of grief. And actually even that is wrong. It should be transaction ID. You're probably yelling at your screen at this point because you realized that already. And again, we can try this. That produced a whole bunch of rows. We don't know if the rows are correct. We don't really know what should be in those rows, but it is appearing that we did create a syntactically correct query to this point, which is good news. We fixed a couple of bugs. Before the query got so complex, they would be even more difficult to fix. What else do we need? We need $1,000 in total sales. Let's go back to our query and let's add sum TD dot total sales and give that an alias. And it's actually not total sales, is it? It's total price. Can we run that? I'll bet you we can't, and hopefully you realize why. It says column store is invalid in the select list because it is not contained in either an aggregate function or a group by. So we have a group by. We have an aggregate function here, sum, but we have a store column which is not aggregated and does not appear in the group by. So there's a conflict. We could fix that by adding the group by right now. Group by store and then try to run it. And good, we're getting a lot closer now. Look what we got. We rolled up our result set by store. We grouped by store, and each store has a total sales. We're getting close to what we want here. We have all the stores with their total sales. We have not applied the filters. We have not applied the where clause. We have not applied the having clause. The where clause needs to be stores in Ohio. Now how do we do that? Let's look at the store table. There's a column called state, and that column appears to be a 2-character abbreviation. In my where clause, s dot state equals OH. That'll filter only the stores that are in Ohio. The having clause is going to be used to filter total sales, because that's an aggregate that's computed after the order by takes place. The having clause will say having, and I'm going to use my alias here, having total sales greater than 1,000. And we continuously test. I added the having clause and I immediately tried to run the query even though I'm not done doing incremental testing, and I see there's a problem. And I will help you with this problem. The problem is I need to use the literal aggregation and not the alias. And there we go. Applying the having clause reduced our result set to 5 stores, all of which have sales totaling over $1,000. And the question we need to answer needs to be sorted. We want descending order by total product sales. So go back here to the order by, and now I can use this. Order by total sales, descending, test, and there's my solution. What stores in Ohio have total sales over $1,000 and descending order by total sales? Let me emphasize again the value of incremental testing and the value of building your little template of clauses and then filling in the clauses one at a time, and then testing as you go. Because if you wait till the end to test, you may get an answer or an error message that you don't understand. But by testing incrementally, you've got a smaller set of SQL to fix, and you'll get error messages that might make a little more sense to you. At this point, I strongly encourage you to practice. You have access to these tables. You can create your own tables in your own database. You can add your own data to the tables. And then you can write queries against my tables in the grocery store database, your tables in your database, and you can practice. The only way you're going to learn this is to practice. You can watch me do it. You can follow along, which I strongly recommend. But until you write your own queries, you're not going to get good at doing this kind of work.